Hey everyone, welcome back. On behalf of Forge College, I'm absolutely stoked to have you here. If you haven't yet, definitely go check out forge.college to learn more about what we're covering today, plus a whole universe of other Web3 topics. Now, today we have a super important explainer for you. It sits right inside the Advanced Function Implementation module of our Functions and Modifiers in Solidity course, which, of course, is a key part of the Solidity from Zero track. Today we're unpacking overloading and overriding practices. Let's get right into it. To kick things off, let's think about this architectural philosophy. Overloading is offering multiple doorways into the same room. Overriding is renovating the room behind the doorway. This quote perfectly captures the high-level difference between these two intertwined concepts. I mean, sometimes you just need a different way to get into your code, right? Like a front door, a side door, maybe a pet flap. That's overloading. But other times, you buy an old house, you look at the kitchen, and you realize it's just terrible, so you completely gut it and rebuild the whole thing from scratch. That, my friends, is overriding.
Let's contextualize this for a second. So, in Lesson 1, we broke our brains just a little bit with recursive function patterns, right? We learned how a single function can handle repeated logic just by calling itself. Well, today in Lesson 2, we're expanding our toolkit. We're moving from that single function mindset into managing multiple function forms that provide related behaviors. And this is going to perfectly set the stage for Lesson 3, where we'll dive into modular function groups.
Here's our blueprint for today's explainer. We'll start with moving beyond single functions, then look at overloading, our doorways. After that, overriding, our renovations. Then we'll peek under the hood at the EVM, walk through a practical example, and finally, wrap up with some best practices. All right, let's jump straight into Section 1, Beyond Single Functions.
So, think back to recursion. It's elegant. Single entry point, nested logic, keeping everything centralized. But let's be honest, it can be a headache. Today, we're stepping up to polymorphism. Yeah, it's a big fancy computer science word, but it really just means using multiple entry points with varying logic. We're essentially upgrading our engineering toolbelt to handle situations where we need similar behaviors across totally different inputs or across inherited contracts. It's a huge step up in flexibility.
Which brings us to Section 2, Overloading. Remember those multiple doorways?
Overloading is actually pretty straightforward. It just means defining multiple functions with the exact same name, but with different parameter types, all sitting right there in the same contract scope. Imagine you're building a token sale contract. Sometimes a user wants to buy tokens by just passing in a price as a standard number, a uint 256. Easy. But other times, they might need to pass in a complex struct with extra metadata, like a referral code. Well, overloading lets you name both of those functions by tokens. You're giving your users flexible inputs for the exact same conceptual operation. Honestly, it's a massive win for the developer experience.
But, and there's always a but, right? There are some strict rules here. First off, overloading is resolved at compile time. The Solidity compiler is smart. It looks at the arguments you provide and literally picks the best matching doorway for you. Second, the parameter types must differ. Third, parameter order absolutely matters. A function taking an address and then a uint is seen as completely different from one taking a uint and then an address. And finally, and please mentally highlight this one, changing only the return type will not create an overload. The compiler will throw an absolute tantrum and your contract just won't compile. The inputs have to be distinct.
Okay, flipping the page to Section 3, Overriding. Time to put on our renovation hard hats.
So while overloading gives us those multiple doorways, overriding is a runtime substitution mechanism. This is where a derived or child contract completely replaces a base contract's behavior. Imagine you have a generic payment processor base contract with a default settlement function. If you deploy a highly specialized version of that processor, you might need entirely different settlement logic to, save on gas costs. Overriding lets you specialize that behavior. But listen, Solidity doesn't let you do this by accident. You have to use specific keywords to officially sign off on the renovation.
There's a very rigid syntax for this. Step 1, in your base contract, you explicitly mark the function with the virtual keyword. This is basically you telling the compiler, hey, I'm officially allowing future developers to renovate this room. Step 2, your new contract inherits from that base contract. Step 3, in your derived contract, you rewrite the function and mark it with the override keyword. The compiler basically forces this explicit handshake so you don't accidentally swap out crucial behaviors and introduce massive bugs into your smart contract. Moving right along to Section 4, Under the Hood with the EVM. You might be wondering, how does the Ethereum virtual machine actually tell these doorways apart at runtime? Well, the answer is the function selector. See, the EVM doesn't read English function names.
Instead, it uses a selector, which is just the first 4 bytes of the kechek256 hash of the function's signature string. Because overloading requires different parameter types, something like foo unt256 and foo address produce completely different signature strings. That means they hash into completely different selectors. So to the EVM, overloaded functions aren't even related. They are mathematically separate doorways.
All right, theory is great, but let's see this in practice. Section 5, practical example.
Picture a vault contract and a custom child contract called custom vault. If we call deposit with just 100 versus deposit with 100 and an address, you're seeing overloading in real time. The EVM routes them to different signatures within that same vault. But what if we call process? Well, if the original vault had a default process function marked virtual and our custom vault renovated it using override, the EVM routes directly to that custom logic, completely ignoring the base implementation. It's just brilliant. Doorways and renovations working together in perfect harmony.
Okay, let's wrap this all up by looking at how the pros handle this. Section 6, best practices. Here is the ultimate workflow to keep your code clean and your gas costs lean. Step 1, define a single canonical core operation. Put all the heavy, complex logic in one place. Step 2, add what we call thin overloads. These are just extra doorways that format the user's inputs and then immediately pass them or delegate them to that main core operation. This saves you from duplicating code. Step 3, only use the virtual keyword when you are explicitly providing a safe default that you actually want others to customize later.
And definitely watch out for these architectural pitfalls. First, be aware of selector collisions across contracts. It's rare, but it happens, especially with proxy patterns. Second, if you're using multiple inheritance, like inheriting from 2 contracts that both have the exact same function, you must explicitly declare all sources in your override specifier. Third, instead of making 50 overloaded doorways that eat up your gas, sometimes it's way smarter to just pass one descriptive struct. And finally, test. Rigorously test both your parent and child overrides. It's the only way to be absolutely sure your doorways open correctly and your renovations don't cause the roof to cave in.
So, I want to leave you with this question to chew on. In your current project, which functions need multiple doorways and which ones need a full renovation? Take a look at your code base today with this new mental model. Anyway, I want to sincerely thank you on behalf of Forge College for hanging out with me for this explainer. Be sure to head over to forge.college for more deep dives into Web3 development. Get that code organized because in our next lesson, we're taking all these concepts even further to build modular function groups. Until then, happy coding!